Alright, welcome back. Now, we have done a lot of integration techniques. We have done a lot of them. We start by integration by substitution, and in fact, a whole lot of integration by part, how to take the integral of a function when two functions is being divided, and that is partial fraction decomposition, and also, in fact, a whole lot of it. The idea by applying the completing of the squares, a whole lot by splitting, by all that. Very good, and also half angle, trig substitution, and all that. Very good. Now, we are going to do another interesting thing here, and that is hybrid substitution. Hybrid substitution. Now, don't forget that the idea of hybrid substitution can also be applied in when we are solving for integration by use substitution, whereby we set, you see that we look at two methods in solving integration by substitution, whereby you set the inside, and the inside it can be this or in terms of what? A bracket. Alright, very good. Then we say that, oh, if it is, then you set your u to be equal to the whole of this, not just that the inside. Alright. The hybrid substitution is generating the same idea, but with this one, something new is coming. There is going to be something new here, but it's still the same idea. Alright. And I encourage you to get the understanding of the hybrid substitution. In fact, it's very easy. It makes the integration very easy for you to integrate. Alright, very good. So let's look at the hybrid substitution. The hybrid substitution. Very good. Now, let us consider other examples whereby the integral is involving with, let's say, involving with as plus n. Sorry, as plus b. Let me make here n. You know that when we write just a square root means that here is 2, but we don't write it. But if I write n here, it's representing square root, cubic root. Where here is 2, where here is 4, it can be 5, it can be 6, it can be anything. Alright. We are saying that if you have an integral in terms of such thing, let's say square root of as plus b, what we are saying is that your substitution is not just going to be u is equal to the whole of as plus b power n. No, it's not going to be like that. But it's just going to be u, which is equal to, now you have to check the power here. Alright, if the power is n, here will be n. That is how we are going to do it. If the power is n, sorry. What I'm saying is that we are not going to set u to be equal to the whole of this, like what we did in u substitution. No. Here, we are going to only pick the inside, which is as plus b. Then we are going to raise this to a power, and that power is not any other power but just this power of what? N. So if here is 2, here will be 2. If here is 3, here will be 3. If here is 4, here will be 4. It's going to be like that. And you can link it to the one we did in the u substitution. As I said, it's still the same thing, but you just watch and see. U is equal to, now this is the same as, I hope you can see that. So for you to remove it, you multiply here by n, then you multiply here by n. Alright, so you get u raised to power n is equal to as plus b whereby this one will vanish. So it's still the same idea, but this idea, you get a straightforward by doing it this way, then you're almost done with the work. It's not difficult. And it's not always that here is going to be ax plus b. It can be only ax. It can be only ax. You can let it square root of ax, something like that. I hope it's clear. Alright. So that idea is the same as what they're going to generate, which is hybrid substitution. So let's move on to solve our first question. Now, with the first question, examples. 1. Integrate 1 over 1 plus 2x. One plus square root of 2x dx. We are integrating this function as respect to x. So what the first thing to do, that is, you can see that this question is in terms of what? A square root of something. Oh, then I can apply the idea of hybrid substitution. And what is the idea of hybrid substitution is saying? It's saying that with this, you set the u to be equal to the inside, and the inside is 2x. And you know for sure that here, if it gets a square root, that means that here is 2, but we don't write it, so you can't square it here. Or u is equal to 2x. Then u is equal to, or to remove the roots, what will you do? You square both sides. So you get u square is equal to 2x. It's still the same thing. How we can see that? Very good. So we remove the root before we take our derivative. From here, we are going to take the derivative. So you remove the root before you take the derivative. But what we previously did in u substitution, for that one, the moment you set your u to be equal to that, then you differentiate. You don't remove the square root. So you can see that it's not the same thing like what we are doing here. Okay, very good. It's a technique, and a technique is a technique. So do it aside. So let me try out this. This is just for you to understand what I'm doing. So right after here, then you differentiate. Differentiate this. You know that we are differentiating as respect to x. Alright. So this becomes an implicit, whereby you use general power rule. So 2u times du dx, which will be equal to differentiate this, we are going to get 2. Then since you want to do the substitution to this side, you move on to make dx the subject. So quickly you can see that the 2 will cancel. So dx is equal to u du. Very good. Very good. Now, having that, then we are going to do the substitution. Alright. You know that this dx can multiply this, so we can get dx here. And the dx is u du. 1 plus square root of, now watch. You can clearly see that, here, we know that u square is equal to 2x. So, for you to get u square is equal to 2x, it means that it's coming from where u is equal to square root of 2x. It's coming from where u is equal to square root of 2x. Alright, we have already established that, but just that print that part. Therefore, the whole of square root of 2x here is u. Now, the next thing to do is to go and integrate. Now, this 1 plus u, we can write it as u plus 1 du. You know, we have already established this technique that if the power here is the same as the power here, you know that here is power 1, here is power 1, then you can move on to make it create and destroy, because we have u plus 1 here, so we try to add plus 1 here, then you destroy it. Exactly. But if here is u minus 1, the minus will come before the plus. The minus will come before the plus. So here will be u plus 1 du. And that is going to be equal to u plus 1 over u plus 1 plus, hope you can see that, sorry, minus 1 over u plus 1 du. Because we can split it. So here is 1 minus 1 over u plus 1 du. So integrate 1 as respect to u minus integrate 1 over u plus 1 as respect to u. So when you integrate this, you get u minus. When you integrate this, you get u plus 1, then you add plus c. It's very, very, very important. Don't forget your plus c after integration. Alright. That reminds me something, but I won't tell you. Alright, very good. So now, after getting this, okay, so we know u is equal to this, right? So after getting this, then we now go and do substitution of our u. Alright, so here is square root of 2x minus square root of 2x plus 1 plus c. So that is the final result for solving such question with the idea of hybrid substitution. I hope you are enjoying it. It's not difficult. Just take your time and do it. Alright. Now, just take note that, as I said, it's not always that you are going to get it like square root of ax or square root of ax. But it can be square root of ax plus 1b. Let's look at such example. And it's not always that you are going to get a constant on the numerator. So let's look at example 2. Alright, this one is in the form of a definite integral. Negative 1 over 3 s over this square root of cube root, alright, cube root of alright, so what do you think we can do about it? You can start thinking about it, or you can pause the video and solve it. So looking at what we have there, we have this. So let's set u to be equal to 3s plus 2 over 3. Oh, we can see that. Then to remove this, what will you do? You keep both sides. So u raised to 3 over is equal to u raised to is equal to 3s plus 2. So the same as writing u is equal to the inside. Then you raise the u to the power of the 3a. I hope it's clear and it's well understandable. Very good. Then from here, what will you do? You go and differentiate. 3 du ds. Hey, what is happening? General form 3 u squared du ds implicit, which is equal to 3, and this will be 0. Very good. Then you know this will cancel this. Therefore, ds is u squared du. The 3 will cancel, and the ds will multiply both sides. So we get that. Very good. Now we move on to go and do the substitution. Alright, so let's go and do the substitution. So we know that everything down here is going to be u. Very good. Everything on the denominator is going to be u. And that is u. Alright. That's what the assembly showed before multiplying or multiplying both sides by power 1/3 or power 3. Very good. Then the ds is u squared du. But what do you think is going to be this x? What do you think is going to be this x? We can get the x from here. Alright. If you know that u raised to power 3 is equal to 3s plus 2, then 3s will be equal to u to the power 3 minus 2. And s will be equal to u to the power 3 minus 2 over 3. Hope you can see that. So we can get our s from here. I hope you are following. Very good. Therefore, I want to take my time and give you all the steps. Therefore, we can get our s to be u to the power 3 minus 2 over. Now, the 3 will now multiply the 1 on the denominator. So we get 3u. Then there will be u squared du. Hope you are following. Very good. This is just algebra. Alright. Then here we are going to get the integral of u to the power 3 minus 2 over. Not forgetting that here is u squared, here is u. So one of it will cancel what we have here. Then we get here to be 3. Then here will be left with 1u. Then you bring the operator, which is du. Very good. You still continue with the algebra. Here, the u here will multiply everything here. So we get u multiply u to the power 3 minus 2, all this over 3. Du. Alright. So we now move on back. We have the constant here to be 1 over 3. So we can plug that out. We can plug that out. So I would like to clean this part. You can still pause the video and continue with it. After that, you come back to check whether you are on the right path. So 1 over 3 coming out, we left with integral u power 4 minus 2u du. Interesting. After everything, we know that our u is equal to cubic root of 3s plus 2. So we are going to replace here by u. Now the s here, how are we going to get the s? we know that u to the power 3 is equal to this. Then our s will be equal to this. So by substitution, you will get this. Not forgetting that the 3 here will multiply this, then this one will turn the numerator. Then after that, this one of it will cancel this, and we are going to get that. Very good. And the u here is going to multiply with a here. And that's exactly what we have done. The constant is 1 over 3, and that is out. Very good. So let's move on and solve it. So here we have 1 over 3, then you block the 1 over 3 because the 1 over 3 is going to multiply the inside. Now when you integrate this, you get u to the power 5 over 5. Minus, when you integrate this, you get 2u squared over 2. Then you add plus, yes, never forget. Don't forget it. Don't forget it. Alright, so we end up getting u raised to the power 5 over 3 by 15 minus this will cancel this, so we get u squared plus c. Hope you can see that. But this is not, here is the final answer, but not the final answer. Not exactly the final answer. So we need to go back and look for our u. The reason is that the question was given to us in terms of u. So we have to bring back our what? Our u. So we go for the u. So where is the u? We know that u is equal to, oh, that is cubic root of 3x plus 2. So we come back to conclude our final results. I should have printed it, right? Don't worry. I like what I printed. So I don't want to do this. So here, but u is equal to cubic root of 3x plus 2. So raising to the power of 5 over 50 minus raising to the power of 2 plus c. And that is the final result for set. Very good. And let me see if I can get one more person for you to try it on your own. And I will give you the final answer so that you can work towards it and see if you are understanding is well fit. So we have one person here that you can use this idea to do it. Alright, so that's it. That's it. You can use substitution like what we did previously to do that. But you see, using use substitution here, it's going to be something else for you on your way. Alright. So I would like you to go with the idea of hybrid substitution, whereby you set u to be equal to square root of 2x minus s squared. Alright. So u squared is going to be 2x minus 2x minus s squared. Then you move on to take the derivative and you end up getting something interesting so that you use that one to do it. Alright? Very good. So continue with it and your final answer is going to be, when you do that, your final answer is going to be sine inverse. Sine inverse I'm going to get sine inverse of x minus 1 plus c. That's going to be your final result for search. Alright. Now, let me chip in this. With this question, you don't want to go by this and you want to use substitution. You can do it by use substitution, alright. But But you have to apply your algebra. You have to apply your algebra work, because you know that with this, when you do this by use substitution, I will not solve it for you, but I just want to chip in something. You see with this, you have this to be integral of 1 over square root of 2x minus x squared. Here, use substitution will not help you. You see that use substitution can't help you here. Alright, very good. And you know the reason why I'm saying that. Yeah, even if you factor x out, you get 2 minus x. You get 2 minus x. And with this, you still can't solve it by use substitution. You still can't solve it by use substitution. So the only thing that you'll be left to do is to pick the inside. You know the inside is negative x squared plus 2x. Alright? Pick the inside. Yeah, it's the same as this. When you pick the inside, it's negative x squared plus 2x. Then you complete the squares. Alright? So you complete the square inside. When you complete the square, you are going to get something like 1 minus. So this is equal to, let me write it here. This is equal to 1 minus x minus 1 all square. When you complete the squares, here, you clearly see it to be equal to this. That is when you don't want to use the hybrid substitution, but you want to use use substitution. So when you complete the squares, you are going to get something like this. And you know how to do complete of squares. The coefficient is negative 1. Multiply throughout. Multiply, you know the process. You know the process. Alright. Very good. So after that, then you come and write 1 minus x minus 1 all squared dx. So with this, you see that now it is clearly that you can do use substitution. I hope it's clear. It's clearly seen now that you can do use substitution, because you know that u is going to be x minus 1. Therefore, u is going to be ds. The u is just going to be equal to what? Ds. And by substitution, you get the integral of 1 over square root of 1 minus u squared. Alright, which is du. And this is what? Sine inverse. This is just sine inverse. Sine inverse. Sine inverse of u over sine inverse of u. Sine inverse of u plus c. This is just sine inverse. In fact, I'm almost done something. This is just sine inverse of u. And you know that u is equal to x minus 1. And you are done with it. That is exactly what you're going to get. But you can also use hybrid substitution. Alright, I am done with the question. In fact, take your time and enjoy integration techniques. It's very, very, very interesting. Alright. In our next video, we are going to look at our last technique, and that is mixture of roots. Mixture of roots. So don't go anywhere. Go and play the next video and let's look at it.